Hello, Mr. McGrath here. I'm going to do a lesson on introduction to triangles. But I need to have a joke of the day. In this case, the joke of the video. Uh, why is the obtuse triangle always upset? It's because he's never right. All right, that's actually a pretty good joke to lead into this because the first thing we're going to do is we're going to classify triangles. As you can see, we can classify triangles by angles. Obtuse, yes, and that means that one angle, yeah, right here, is greater than 90 and less than 180. And then we can also have a right triangle, which has exactly one right angle. And then we can have equal angular, which all the angles have the same measure. And then we can have an acute triangle, where all the angles are acute. Now, we can also classify our triangles by the sides. Yes. The first one, equal lateral triangle, all three sides are congruent. And then isosceles, at least two sides are congruent. And then the scaling, where no sides are congruent. So, as we jump into this, we can see the first thing we have to do is classify the triangle by its angles. And so here we have triangles named by their vertices, triangle PQS. And if we notice, yeah, that right here on the other triangle we have a right angle. And since this makes a line, that also means that this is a right angle because they will both have to add up to 180. So triangle PQS is a right triangle. Well, we already know that the one on the left here is a right triangle. So that means the one on the right has to be a right triangle because one angle is a right angle. All right, lastly, PQR, triangle PQR, the big one where you have two of the triangles added up, yeah, to make the big one. And so if I look here, I have these two angles, yeah, and if I add those two angles up, I get 104 degrees. So that means we have one angle in that big triangle that's obtuse. So this is an obtuse triangle. Now on the next one, we're going to classify the triangles by their sides. Yeah, and they give us some information. They say M is the midpoint of the side JL. Well, that's good information because that means these two are congruent. And 1.5 divided by 2 is 0.75. So all these are 0.75. Anything that has a congruency mark actually is 0.75. Wow, we got a lot of stuff going on there after just noticing we have a midpoint of J, a midpoint there. All right, so let's look at triangle JKM. Well, if they're all 0.75, that means it's equilateral. And then KLM, well, only two of those, yes, are congruent, so that's going to be isosceles. Lastly, we have the big one put together, JKL, so we have 1.5, 0.75, and 1.3. That's going to be scaling. All right, so now what we're going to do is we're going to have some algebra applied to classifying triangles. So we have in front of us triangle ABC. and we have to find the side lengths. We see these two congruency marks right here, and so we know that this is isosceles. Yep. And so since they're congruent, and we have to find the lengths AB, AC, and CB, these two are congruent. So their lengths are equal. So then we can substitute our values in. For the length of AC is 4x plus 1. And the value for BC is 5x minus 0.5. I'm going to subtract 4x from both sides and get 1 equals x minus 0.5. Then I'm going to add that 0.5 to both sides. Not 0.05, 0.5. And I get 1.5 equals x. And then I have to plug those values in. All right, so here I have, for AB, I have 9 times 1.5 minus 1. Well, that's going to give me 12.5. And then I have 4 for AC, 4 times 1.5 plus 1. Well, that's 7. Then lastly, I have 5 times 1.5 minus 0.5, and that is 7. And it makes sense because AC and BC, they're supposed to be congruent. That triangle is isosceles. All right, in this last example, we have an equilateral triangle. So that means all the sides are congruent. So we can pick any of the sides and set them equal to each other because they're congruent. And so I'm going to pick, let's see, FH being congruent to GH. And since they're congruent, we can set them equal. And GH is 3y minus 3. And then I got to solve these. All right, so I'm going to subtract that 3y. And I get 2y minus 19 equals, negative 3. Then I'm going to add 19 to both sides. And I get, let's go over here with it. 2y equals 16. I'm going to divide by 2. I get y equals 8. And now the nice thing is since they're all equal to each other, I can pick whatever one I want to plug that y into, and I'll get all these lengths because they're all going to be equal to each other. So I'm going to pick FG. So let's do that. FG equals 2 times 8 plus 5. And so that gives me 21. Since that's 21, that means all of them are 21. Okay, this is angles of triangles. So what we're going to do is look at this triangle sum activity. So I know I can't pass out triangles to you and work with you, but I'm going to show you. So here's a beautiful green triangle. It's been used a lot over the years. And you've always known, yes, that the sum of these angles adds up to 180. That's like one of these things you learned as a youngster. Yeah. But this is going to be a visual proof of it. Throughout the year, we talked about a linear pair. And when two angles are added together on a line, it makes 180 degrees. Well, this works for any number of angles. If you put them together and make a line, they will add up to 180 degrees. So in fact, you can fold a triangle so that the angles will make a line. And that's what I'm going to do right here. And so this is the triangle sum activity. So I'm folding angle 1 to the left, angle 2 down, and angle 3 right. and you see that I make a line out of the three angles. And so this is a visual proof that the sum of the three angles of a triangle will add up to 180 degrees. And then you can use that to help you solve some problems. Here we go. We have a lot of triangles in here. Yes, we have three that we can look at. If we look, yes, and we say the measure of angle, let's do the measure of angle 2. That would be nice. Let's just use that idea. We see angle 2 is a part of this triangle KLM. If I add those two angles up that are there, 57 plus 71, I get 128 degrees. So using this triangle sum theorem, I can subtract 128 from 180 and get 52. There's a 2 there. That's nice. 52 degrees right there for angle 2. And then let's see. Oh, that's cool. That's nice to see. Let's look at angle 1 now. And if you notice on angle 1, yes, look at that. We have a linear pair being made. So I can use an old idea. So I get 180 degrees minus 57 degrees. Well, that's just 123. So you can also use old ideas. That's 123. Now I'm going to use the triangle angle sum theorem to find this angle 3. Once again, I have these two angles here. I can add them together. And I'm going to get 151. And then to find the measure of angle 3, I'm going to subtract that from 180. And that's going to give me 29. Sorry about the bell. And there's an announcement.
This is just a quick reminder. Please do your upbeat survey today before you leave. I really want us to be in that drawing for the queso drop. I'm going to imagine that it is essentially they just fill up a big kiddie pool with queso and we get to swim in it. So, I want to be a part of that. Please make sure you do the upbeat survey. Thank you.
So kids, that's pretty funny. I hope we get the queso. I did the survey. That's pretty hilarious. We're keeping that in the video. All right, so we're going to move on to something that is as cool as queso. It's called the exterior angles theorem. So I need to show you how an exterior angle is made. So basically what you do is you have a triangle, and one of the sides is extended and it makes an exterior angle. Now there's a cool relationship between the exterior angle and these two remote interior angles. All right, so what the relationship is that if you see these two angles, I copied them on this patty paper. And if you know anything about, angles of a triangle, yes, once again, that adds up to 180. And also, if you have a linear pair, it adds up to 180. Well, the exciting thing is these two angles you can rotate, move over here, and you can see, oh my goodness, the sum of these two remote interior angles are the same as this exterior angle. And that is the exterior angle theorem. And so now what I'm going to do is I'm going to define what an exterior angle is and a remote interior angle. So, and what we learned just from that nice little movement of paper is that the exterior angle, luckily, is the sum of the remote interior angles. So once again, an exterior angle is formed by extending one side of a polygon. Yes. And remote interior angles are angles not adjacent to the exterior angles. And once again, they're on the interior of the triangle. All right, so let's just practice this a little bit. So if on here I say this is 100 degrees angle B and A is 20 degrees, then if I call that angle 1, then the measure of angle 1, because it's the exterior angle, it's going to be the sum of these remote interior angles, which is 120 degrees. Pretty easy. So now let's do some other problems. Oh, we got a bow tie. And I'm going to use this new idea as much as I can. For instance, angle 2 is an exterior angle for the triangle on the left. And since it's an exterior angle, 35 and 75, they're not adjacent to angle 1. Those are the remote interior angles. We just have to add them up. So we got 75 plus 35 degrees. So that is 110. So this one's 110. All right, and so let's use that idea again. We know that this is an exterior angle, yes. 110 is an exterior angle, but it's an exterior angle for the one on the right. And so 110, which is an exterior angle, is the sum of the two remote interior. So that's 28 degrees plus the measure of angle 3. So if I subtract 28, I'm going to get 82 degrees for the measure of angle 3. And lastly, we need to get the measure of angle 1. Well, we could just use a linear pair on that one. That's pretty easy. And so if I go to use a linear pair, I'm going to do, all right, angle 1's a linear pair of 110. So I do 180 degrees minus 110, and that's 70. And man, oh man, I hope we get that queso. All right, that's the end. And maybe we will get that queso. That would be real nice because we deserve it. All right, so the last thing we're going to do is we're going to look at inequalities in one triangle. But before we get there, we need to talk about sides and angles of triangles. So if we look at this equilateral triangle on the right, DEF, I'll slide it over a bit, we know all the sides are congruent, and that's called equilateral. But an equilateral triangle is also an equiangular triangle, meaning all the angles are congruent. So these are all congruent. And if we wanted to find the measure, say, of angle D, we know that since they're all congruent, we would just divide 180 divided by 3, which is 60. And so there's a connection between angle and the side opposite it. Yes? And so with all these congruent angles, the sides opposite them are also congruent. So if we look over here at triangle ABC, we have an isosceles triangle because AB and AC are congruent. Well, the cool thing is that these angles opposite these sides are also going to be congruent because these are the base angles of an isosceles triangle. So if someone tells you, oh, I got this vertex angle here that's 20 degrees, you can then find the measure of angle B and C because we know that these two are congruent, because the sides opposite them are congruent. So if we want to know how much is left between the two of them, we go 180 degrees minus 20 degrees. Yeah, that gives me 160. And so if I want to find the measure of angle B, which is the same thing as the measure of angle C, I'm just going to do 160 divided by 2, which is 80 degrees. Which is a very important idea because it helps us solve a lot of different problems involving equilaterals and isosceles. Okay, so now we're going to look at inequalities in one triangle. So inequalities in one triangle, yes, we're talking about sides, yes, and we're talking about angles, yeah. So as it states here, we know that if all the sides of a triangle are congruent, then all the angles are also congruent. So, but what happens if all the angles or all the sides aren't congruent? What goes on? Well, the cool thing is, if you look at this triangle on the left, yeah, and actually they're the same triangle, if we see the largest angle B, opposite is the longest side. And over here, angle A is the smallest angle, and opposite is the shortest side. So that's pretty obvious to everyone. This is why I like geometry. There's a lot of obvious things. And it's easy to remember because the longest side and the largest angle are opposite each other. The shortest side and the smallest angle are also opposite each other. All right, so there you go. So have some simple ideas. This is the beauty of geometry, not making it very complex. And then these two theorems just restate it, and then we can put it into practice. So the only thing that makes this difficult is you just have to read what they say. Like for instance, we have to put the angles in order from smallest to largest. Notice they give us side lengths, yes? So we go smallest to largest. Yeah, the smallest side length is here. Yes, and I'm going to put the biggest, obviously, or the largest is going to be this one. And so this is the middle one. And so then you have to put the angles in order. We organize the side lengths. So the smallest is going to be opposite it. That's angle Q. The one in the middle is the one opposite 8.8, yes, which is R. And lastly, the largest angle is opposite the longest side, which is P, angle P. QRP. All right, so then we have put the sides in order from shortest to longest. So once again, sides from shortest to longest. The only thing you notice is we're missing this angle here, and it'd be good to know what that angle is. Luckily, we know all three of these angles add up to 180. So 45 plus 56, that's 101. And so if I want the measure of angle F, I'm going to do 180 minus 101. So the measure of angle F equals 79 degrees. All right, there's 79 degrees. We just found our largest angle. That's my largest angle. This is the middle angle. And this is obviously the smallest angle. So if I want to go side shortest to longest, the shortest side is going to be opposite the smallest angle. Yeah, so that's FH, that side. And I'm going to use this segment because it is a segment. The middle is opposite the middle angle. So boom, side GF, that's a segment. And then lastly, the longest side is opposite the largest angle. So GH is the longest side, and that's a segment. And there you go. There's your lesson. This once again was talking about isosceles triangles, equilateral triangles, which are also equal angular, and then looking at inequalities in one triangle. Thank you so much and have a great day.